Hi, so welcome to the tutorial for Ultimate Trace plugin. So how I'm gonna go about showing you all the different traces that this plugin has is I'm gonna do it in the first person character. So basically in here we have the primary action, which is basically when we click left click. I'm just gonna add some additional functions and settings to kind of showcase each of the traces that we have. I'm also using my demo level that you can find in the plugin. So in here you can just step on any of these triggers and you can see exactly what each trace does. So in here you basically have everything, and if you ever wonder how each of them works, you can go here to level blueprint, and in here you can see all the different traces. So we have bone trace, camera corner trace, and you can see just how I set the things up to kind of showcase each of the plugins. You can see, of course, the settings for each of them. So let's go to the first person character and let's right click and type Ultimate Trace. So when you type this, you should get all of the functions in basically any actor blueprint, and you can basically click any of them and use them. So let's just go from the top to the bottom. So I'm gonna click on bone line trace, and basically how this works is we need a skeletal mesh. So we have our mesh here. Let's do this. And let's bone name, I think, and L is 1. Let's do 500. And x-axis should be forward. And I'm gonna, for each of them, change the trace settings so we have it persistent for debug, so we can actually see what you're doing. So let's compile, save, and let's go into the game. And now when I click left click, we can see how I'm casting the traces. Now I am not sure if I'm casting from the hand. I don't think I am. So let's just check our skeletal mesh. Oh yeah, we're using first person mesh. That's my bad. Let's change this. Let's see. Now you can see we are casting in different direction, and it is determined by our hand bone basically. So pretty easy and straightforward. All of the bone traces have just few simple options. So trace length is something that I think all of them have, meaning that all of them you can determine the length of the trace that you're actually casting. And then you have some additional options that are specific to the specific trace. So if I type ultimate trace, so bone sphere trace is basically the exact same thing. The only difference is that you have the radius of the sphere trace. And we can quickly overview that. So I'm gonna type hand L. And let's do 5. So now you can see we are casting the sphere trace and everything works exactly the same. Okay, let's delete this. Let's type ultimate trace and let's see camera corner trace. So this has even less options because you just need to provide the camera component and then everything else will be done for you automatically. So let's do 500 again and let's make it persistent. And you can see from our camera we cast 4 rays in 4 directions, and right now we hit 3 objects, so we are gonna get in our output we're gonna get 3 hits basically. So as you can see, we can just look anywhere and we're gonna cast a trace there. This is of course aspect ratio and field of view independent, meaning that you can change the camera aspect ratio so it would cast accurately if you're on the phone, PC, laptop, or aspect ratio is 16:9, 16:10, whatever you have, it will work properly. Now let's see. Yeah, you have these hit results, and depending on what you hit, you're gonna get the length. So this way you can extract how many objects you hit, and if it's 0, that means you didn't hit anything. And then you can, of course, do whatever you want to with them. You can go for loop or something like that. Next thing, let's see. Class line trace and multi-trace. So these two are kind of different. So multi-traces, multi-line sphere and capsule traces only work with objects that are overlapping only. So if they're blocking, they're gonna block the multi-line. So this is an important thing to keep in mind, that if you have, let's say, 3 objects and you cast a ray from this point, let's say your ray goes through 3 objects, or it should go through 3 objects, but this object is collision is set to block. What's gonna happen is that this the ray cast is gonna stop here and it's never gonna hit these guys. But if it's not blocked, if it's overlap, what's gonna happen is gonna hit this object, then it's gonna hit this object, then it's gonna hit this object if this is also overlap. So whenever it hits the block objects, that will be the last object that it hits. So that is one thing to keep in mind with the multi-line traces, but yeah, we can even test that. Right now, I don't have anything specific to trace against. So let's see, we can just do maybe actor. Now, all of these that are just doing simple line traces, they're gonna have location and the direction vector. And this basically means you need the world location for the object. So for this, we're gonna use our camera. We're gonna get the world location of the camera. And then we need the direction vector. Direction vector basically means if this is our actor, or the location of our actor, in which direction do we want to cast a ray trace or a line trace or whatever. So one thing that we can use here is that our camera, or basically any component, it has 3 things. It has forward vector, which is positive x, so, or local positive x, so meaning that the forward vector for the camera is always going to be here, even if the camera is, let's say, rotated like this, the forward vector is always going to look here. So good thing in here that you can use is forward vector. You also have up vector, so if we look at the camera from the side, let's say this is the side view of the camera, up vector is always going to be here, and then we have the side vector, which is always going to be 90 degrees from the forward vector, so it will look like this. Or in here it would be towards this side, it will be positive and then negative. So what you can do is type get forward vector, and then we can use that to basically always cast wherever we are looking at. Let's set it to persistent again, and now we don't have any specific class, so we can just type actor here, and now we're just casting the traces. Now if we find this class line trace, we can see basically what's happening. So if we just cast, so we can see overlap and block, this is kind of what I was talking about. If I do line trace only hits one object and it needs to block, so it's gonna ignore the overlap and just hit the block. But the sphere trace is gonna hit the overlap first and the block, and we have the objects hit 2 there, saying that we hit the overlap and the block. But if this overlap, or if this block object was also overlap, it's gonna pass through it and maybe even hit the 3rd object, and we're gonna have multiple objects hit. So that's basically what we're doing here. I'm not sure if I could show it in here, but yeah, you can see there how it hit the object. So you can see that we kind of get a similar thing where it hits the first thing and then continues. So let's see. So class line trace is straightforward. Yeah, you just hit the first object. So let's go to the next thing. These are also pretty straightforward. I guess we can showcase the capsule one. So let's get our world location, forward vector. Let's do 500 again. And usually you can do 2 things here. You can split, or you can make the struct. So you can do it like this also. Depends basically on what you may, what is easier for you. So if we change this to persistent, it might be easier to just kind of make it clean like this, or you can also spread it out in here. So we made it persistent, everything is fine here. Now radius, since we're using a capsule, and capsule has 2 things, so for the capsule we are gonna have object like this, and then we have the height, or it would be half height, and then we have the radius, which would be basically this number, but yeah. So let's do radius maybe 10, half height let's do 50, and you can see we cast from the capsule to the capsule, and we can cast as many as we want basically. And this works the same for the sphere and the line, so you don't have to go through them. But yeah, this is the most simple version of the trace, where you just cast in front of you and see what you hit. But you have the options for the sphere and the capsule trace. Capsule trace can be good for maybe tracking if your character could pass through something. So instead of taking the first person camera, you might just take get actor location. So get the location of your whole actor. So let's say this is your actor, and you always want to just, wherever the character is facing towards, maybe you want to just cast directly forward line trace instead of maybe casting from where the camera is looking, because the player could be looking down, and then if you cast here it gets awkward. But maybe you want to see, let's say we have a place like this, and you want to see if the character could pass through this. You could cast this capsule trace with the size and dimensions of the capsule of the player, and then you can basically cast it and see if the player can pass, and if he doesn't hit anything you can okay it and basically say okay, the player can pass through this obstacle. And you can easily get your capsule height and radius from here, and basically get the accurate representation of your character for this. Let's do ultimate trace. Next thing is fitter sphere trace. So this one can be a bit more complicated, but let's try to dismantle it. So I'm gonna use for location of the camera again, forward vector again. Let's do for 500. So basically how this works is that you start, so let's say you want to detect the size or if something could fit in the some hole or something in your environment. You want to see if this object can fit in here. What this is doing is you have two options. You have scale up or scale down. Scale up means it's going to start from the minimum size, go in steps up until the maximum size. So that means it's going to start with 2, then it's going to go to 7, then it's going to go to 12, and that means the radius of your capsule, or not capsule, the sphere. So that means it's going to start with 2, then maybe go to 5, then 7, stuff like that, and it's going to scale up until it hits something. So let's say you have a compartment or something in here, and it might start with let's say this is 2, so it's gonna cast 2, then it's gonna increase the size, cast again, it goes in, then we increase the size, it probably won't go in here. So what's gonna happen is we're gonna cast from here. Now it's a bit too close to kind of showcase properly, but it's gonna try to go in, and it's gonna hit here, and this is where it's gonna stop, even if maybe we can test even higher, but it's not necessary. We already know it hit in here, so this is kind of the size. It cannot go anymore up. And for the other, let me start again this. So for the other, it will be scaled down. That basically means it passes if it doesn't hit anything. That means we start with a big trace, then we go smaller, then we go smaller, and let's say this one could pass, so it would start going in here, stop, and then we won't go any smaller because we already know that this one can pass through the hole. So that's kind of what this fitter sphere trace does. I guess we can showcase it. So it might look a bit weird in the beginning, but basically starts small, it goes up. Now since it starts small and the first one already hits, so you have to pay attention to the length. It already, yeah, worked, but we can do, let's see. So you can see how this second one was a bit bigger than the first because the bigger sphere hit it accurately. So we can see in here. So these ones that are all red mean that they did not hit anything at any point, but this one, when it became big enough, it hit the wall, so we basically detected something. To see it here, I basically created this little test where we go and it says pass if trace doesn't hit. So when it's red inside, that means it's passed, because that basically means it didn't hit anything. It went inside and didn't hit anything. And then this one is pass if trace hits, so when it's green it should pass. So let's see, when it's red it passed, and this when it's green it passed. So yeah, that's kind of this trace. This is probably by far the most confusing one. But it should intuitively be, when you kind of see it, it should kind of be understandable. Then we have the illuminator. This basically means we cast a trace from the location, direction vector, and we can... So now I'm using object types. So this is kind of the reason why I didn't want to create like a bloated, even if I could create like probably in the hundreds of functions. So there is also combination. So if we type line trace, so you have, for each one you have line trace by channel, profile, objects, and you have the same for the multi-line trace. So for each of these, for let's say illuminator, I could create in total, what is it, six or more variations. But then I feel like it will be too much and unnecessary, because nobody's going to use illuminator with capsule trace. That's completely unnecessary, and I just don't see the use ever for it. So I think illuminator for line trace would be mostly used, and then maybe sphere trace I might add that later, or maybe like illuminator where it casts line trace, but then when it spreads out it casts sphere trace or something like that. I can see that maybe, but for now I just added line trace, so it's the most simple one. And I can use the word static, so basically whenever we hit any static object, we can also do dynamic or maybe even pawn. When you hit another player, it kind of scatters. So this one might look a little bit complicated, so we can use make vectors to make it more understandable. So basically what's happening here is that you have your scatter settings. This is similar in a way where we have multiple line traces here. We have one line trace that goes forward, and then when it hits something, it casts multiple line traces in random directions. So I wanted to create different settings for this. I didn't want you to have a same, let's say, length for this guy as it's... So maybe you want a really long first initial trace, but then when it hits something, you just want like small random line traces. So I wanted to kind of separate that, so you have that option. So that's this scatter setting. This is the scattering rays, which you can have multiple of. So let's say let's do a really high number, like 400 or something. And let's say they are really small, maybe 200. And for these, yeah, we can leave it at 500, maybe even more, let's say 800. Let's see what else we have. Object types. So maybe when it scatters, we only want to hit the pawn. So this is also a good thing. Maybe you want different things so maybe whenever you hit anything in the world, then this scatters, and we only care if it hits the player. So maybe you have like a rocket launcher or something, and you hit the wall, and you want it to kind of explode in shrapnel. You can maybe just test if shrapnel hits the player. You maybe don't really care if the shrapnel hits the wall, so you can kind of figure out what you want to trace with what. And then we have the trace settings for the initial ray. So let's make this persistent, and that should be fine. And you can see that for most of them we have this location directional vector, so that gets pretty simple there. So let's test it out. So when we hit this wall, it should trigger the scattering, and we can see we have that initial ray, and then when we hit, it scatters in all over the place. So let's see if it triggers with us. So you can see since we set it to detect the pawns, we got the pawn hit in here. So that's kind of, now this is probably way too much raise, you don't want 400. I'm assuming for most users it's gonna be between like 10 and 50 raise maybe. But if you want, you could do something like this. But since there is so many rays in here, for this you'd probably just want like a sphere collision that just spawns, detects anywhere on around, or you can actually detect by distance, or you can use different ways to kind of detect. Casting 400 rays probably not the best. So more realistic number might be like, let's do like 30. And maybe the length 400. So if you cast in here, we can see it scatters and we get different stuff. Let's see if we can hit ourselves. Okay, we can. So yeah, that's the illuminator trace. Probably the most complicated to set up just because we have these separate scattering settings. Usually you don't have that, you just have a few basic settings and then the trace settings. Multi-bounce, this one is also pretty simple to set up and fun to play with. So let's split, persistent. Let's make it really high, so let's do 1000. Let's do it can bounce up to 5 times. Trace length, so this is the initial length. Let's do 600 and then we connect it. So reflection trace, that means when it starts bouncing, what the number do you want? So if I click here, we can see this is, I think I put it to 1000 and then the initial array is a bit shorter. So let's see if we can do this. Oh, I don't have the range. Oh, this is, oh, it did bounce, okay. So it bounced in here, bounced here, and then went away here. And I think it hit the object because we have the trigger in here. So I think it hit the trigger, you can see it in there. But yeah, so this is the example of it. So I think I set the 3 bounces in here, so it can bounce around in objects, and if it hits something, you're gonna have the hit results. And we can even do our own hit to see what happens. And keep in mind, for each of these you have the output. It is an array or just a single hit, depends on what we are tracing. All multi bounces are gonna have, or multi-line traces are gonna have an array, but otherwise you're gonna have a single one. So let's do this. Scatter trace. So this is one of the simpler ones. This is basically just if you want to randomly scatter, or you want to just select location and just randomly scatter, you want to scatter in specific direction. So in here the direction vector doesn't do anything because we have the sphere selected, but if you select scatter type to cone, that basically means it's gonna actually cast in a specific cone that you set the direction to. So you could do any direction or even any size of the cone. And in here you can even do like a dome, so we can do something like this. Let's do 50 rays. Trace length, let's do 300. Let's do 90 for half angle. That's fine. Camera, okay, that's fine. So we should do basically like a dome in front of our camera, but we can also choose a different size, but let's first see this. So you can see we basically are casting a dome in front of our camera and it detects anything in there. So if I look up, the cone will look upwards, and in here I can showcase the different vectors that you can use. So you can even do something like this. So this would always point up in the world. It doesn't matter where I'm looking. It's just gonna do location camera and then always point up whatever I'm doing, it's just gonna point up. So you can do something like that. And since this is a cone, we can do like 45-degree angles. And I could do like up vector. So it's gonna be local to the camera. So if I'm looking down, let's say my camera is looking down like this. My forward vector will be here, and then my up vector will be here, so I'm going to be pointing forwards. So if we do something like this, and I cast in here, it's going to be up, because I'm looking forward and it's 90 degrees, but if I look down, it's going to cast forward. So you don't have to always cast forward, it's basically however you want to use it for your project. Let's see what else we have left. Oh yeah, I didn't show the sphere trace, but that's basically just in all directions, you just choose the amount. Threshold multi-line trace. This one is interesting, but might be a bit hard to showcase. So location, direction, let's do 500 and let's do 2. And then we can leave it at visibility. And this basically means that it's gonna hit, it needs to hit more than 2 objects for it to be considered to be passed. So if I click play and I try to hit something, try to hit this, so this wouldn't count because that one passed only through 1 object, but if we cast it in here, this should count because we passed through 3 objects. So in here, this is kind of the example of it. If we try to pass, it's true because we passed through 4 objects. I think in here I also set it to 2, so it needs 3 or more. Or is it... no, it needs... 3 or more, but yeah. So if I try it again, it's going to be false because it only passed through 2. Even though it registered both of them, it didn't go through the third one, so it says, the threshold is not passed, so you cannot... this is not a successful trace, basically. Okay. What else do we have left? So we have basically 2 more. So path line trace. This is basically you select points. You don't even have the forward vector. You just have the group point group. So we can do something like this. And then let's select the player's location. I'm just gonna offset it. So what we can do is local offset location, and we can select our capsule. And this local offset location is also the function that I'm offering, which basically means, if you remember with the camera, depending on where the camera is looking at, this would be the, so let's say, let's make it a little bit nicer here. So let's say this is the forward vector of the camera, this is the up vector, and then towards us it would be the right vector. What local offset means is that if you want to offset the location to, let's say, 30 units on the x-axis, it's always gonna point offset it towards this. That means that if, let's say, your camera is looking up, it's gonna offset towards this direction, but when you look forward, it's gonna offset this. And you can also use up vector, and you can offset it however you want. So you don't have to offset it towards forward, you can offset it down, right, wherever you want, but it's always gonna be relative to the camera. So if I select, let's actually select the camera instead of the capsule, and we want to offset, let's say we want to path trace, so let's do 50 in front of the camera, so 50 units towards front. And how path points works is basically you select points, and then it's gonna cast between those points. Basically means if I have 3 points, and this is the first point, it's gonna cast from this to this, then from this to this. And if it hits anything in between, so let's say there is a 4th point here and maybe the 5th point here. Let's say we have an object here. It's going to try to cast, it's going to hit something, and it's going to say, okay, I'm done bouncing from point to point because I found an object, and it's going to finish the function. So even if there was no object, it would have continued. Since there is an object, it just doesn't, it stops there. So let's create something like this. I'm gonna So let's do 50 here, then maybe 50 here, and then let's do 50 here. So let's see how this looks. So if I have this correct, what it should do is, if our camera is like this, it should cast it so a little bit in front, then the next point should be a little bit in front and right, so somewhere here, and then the next point should be in a little bit to front, right, and then up. So if you look from the side, it should look like this. So let's see. Set it to persistent. So we were casting towards the back. Let's see. Oh yeah, we were offsetting. Okay, I think we need yeah, there is a little bit more work to be done here. So what we need in here is our location, and then we'll have to offset it like this, basically. Or no, oh yeah, sorry. This already happens inside the location. I forgot to just connect this guy here. Let's see. Okay, so basically we get something like that. So first point is here, then we offset it to the right by 50, and then we offset it up 50. So basically we get this shape. And since it's relative to the camera, you can see how it's always gonna be in front of the camera, right and up. So I could be looking wherever I want. It's always gonna happen like that. Now, if you don't want that relative offset, you could do something like this. So you get the world location, and you can just basically add any offset. So you would do like basically something like this. So you would do 50 here, then maybe next one would be 50-50. I guess we can go quickly through this. And then the third one would be 50-50-50. Now, if you have like a pathfinding or something like that, you can automatically get the points and connect them. But I'm doing this manual because I don't have anything generated right now for the points. But if we do this, we are gonna get the camera location, and then whenever, wherever the X in the world is, so if we click on any object, it should be something like this. Or actually it's gonna go like right and this, and then whenever wherever we are looking at, it's always gonna be positioned like that. So that's kind of what should happen. So let's see. So we get right and up, but if I look here, click, we get the same right up, and it's going actually behind my head because the X is going there, so it's 50 points there. So let's look at like this. So you can see how they're positioned the same even if I'm looking different. So if I click here, we can see it's always positioned the same because it's using the world locations instead of relative locations of my camera. Okay, so let's delete all of this, and let's do the last one is tag trace. So the sphere and line trace work the same, but of course, one is a sphere, so you have additional radius option. But let's do this. Well, how this basically works is if any actor has a tag, so let's say, let's put a test tag. And if you have an object with a test tag, let's actually see. Oh, they have a tagged option. So if I select an object, go to details, type tag, you can see how they have the tagged index. You can put anything you want in here. So this is like list of the actor tags. So we can actually use their tag. Persistent, I can even print the length so we can see the difference. Or we can see what we hit. And in here, if I hit something, you can see it says 1, but if I hit in here, it says 0. Even if I hit another object that doesn't have the tag, just gonna say 0. So it's waiting basically for the tag to be hit. I don't think this is, yeah, this is just line 3. I don't think this is multi-line. Oh yeah, it is actually, never mind. So you can see it says 2. That means because this one has tagged and then this one has tagged, it basically goes to both of them. And that's the same thing that I set in here as a test. So yeah, that's kind of it for all of the functions. Honestly, if you just play with it, this is all gonna make sense. You can just change some settings, get the results, see how it looks. And of course, keep in mind, if you ever want to see how anything this level is made, just open the demo level blueprint, and in here you have my setup for all of them. It's a little bit messy, I didn't want to spend too much on it since this is just for the showcase, but you can basically see how I used things. So I was basically using some other actor, get forward vector from it. This is just an empty actor in the level, and it's the same setup that I did for the camera. So yeah, you can basically check it out in here. But yeah, that's about it.